So another way to solve systems of equations is by graphing them. What we're going to do is graph both equations on one grid, and the solution is just where the two lines intersect. Could not be simpler. Now, when we've been solving these lately, we've kind of had three different answer types that we end up with, right? Sometimes we end up with an answer like x and y. Right? You end up with that nice solution, or x equals y equals, and it gives you a nice clean answer. Sometimes you end up with no solution at all. That's one of our special categories. And then the last one is occasionally you end up with that infinite solutions category. So these two, we've been kind of calling them special solutions. That's not a technical term. It's just kind of a way to think about the fact that they work out a little strangely when you're solving them because the variables disappear. This would be what I would consider our normal solution, okay? So our actual, what we end up with most of the time is a normal answer, an x and y answer, okay? So another way you may see this is this normal answer is also going to be considered to have one solution. So you could have one solution, you could have no solutions, or you could have an infinite number of solutions. So here's how this looks. When I graph my two equations, and if I graph, I'm just making up two lines here. Let's say I graph my two lines, and they very clearly have a nice, good, clean intersection right here. Then that's telling me that that right there, that spot where they're crossing, is the solution. And the coordinates of that spot are your answer. The x value and the y value. That would totally work. Well, no solution means that they would never cross. So if we think about how does that happen? If it's got no solution, it means it has no intersection. Well, the only time that happens in math is when you have two perfectly parallel lines, okay? One mistake that sometimes people make is they think, well, if I've got, let's say you have two lines that are kind of like this, and they haven't crossed yet, but I mean, obviously they're going to cross if they continue. They say, well, they don't cross, so there's no solution. Well, no, these two lines will cross. They just haven't yet. So this situation really only happens when they are parallel, okay? Okay, if they never cross, that's the only time you're going to have a no solution off a graph. All right, so infinite solutions, if this is they cross one time and there's your answer, this is they never ever cross. Infinite solutions would mean they're crossing an infinite number of times. Well, the only way that can happen is if you actually have the second line right on top of the first line, okay? So really, only if they are the same exact line. So if I'm looking at equations, it would be the same equation for that, okay? So those are kind of our three little categories. Now, one thing I want to remind you, and I want you to put a note to yourself in down here, is that if you are graphing, I guess I don't really need to capitalize that, but graphing needs a certain form. And so when we were graphing lines, because everything we're going to do is linear right now, we need y equals mx plus b. All right, that's kind of a big deal. So if you don't have an equation that's in mx plus b form, you're going to have to do some math to get it there. All right, for a couple quick examples, these are nice because they're already set up. If you look, this is that nice familiar mx plus b, y equals mx plus b. So let's see, this graph is going to begin on the positive 2, and then I'm going to move up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And I want you to go ahead and do some back the other direction as well to follow that pattern. Remember, you're always going to run to the right. The positive or negative part just tells you whether you're moving up or down. So we're always going to run forward unless you're filling in all these back dots. Second equation is great. It's also already in y equals mx plus b. So this graph is going to begin on -1. And then my slope doesn't look like it's there, but remember you can always fill in a 1 right there. And I'm actually going to even fill in a 1 over 1. So my slope is -1 over 1. So down 1, run to the right. Down 1, run to the right. Well, that's not getting me any closer to my pink line, so let's go back the other direction. Up one and back, up one and back. There you see that intersection, up one and back. So there, it's pretty obvious that my solution is right where they cross. That's the solution. And so now, as far as getting that as an answer, I need to be pretty good with coordinates so that I can actually do this. So let's see, that would be at -2, +1, and I'm going to put them in order so x comes first and then y. So you are welcome to answer this just with an ordered pair. For my people who are really comfortable with the old version, you could always write it as x equals -2, y equals 1. Okay, it's the same thing, all right? So in our second example, first equation looks good. I'm ready to go. Y equals mx plus b. I don't have a b value, so this graph is actually going to begin on 0. And then I'm going to move down 3 over 2. I'm going to rise -3 and run 2. So I'm going to do down 1, 2, 3, and then always run to the right. 1, 2, 3, to the right. Up 1, 2, 3, and back to the left if I'm filling in backwards. I think that's enough, but I'll go ahead and squeeze another one in there. So there's line 1. And I do recommend that you connect them, because what happens, especially if you're not using two different colors, is you sometimes have a tendency to mix up your dots of which coordinate went with which line. This one is an issue because it's not in mx plus b. So I'm going to have to do a little bit of work to isolate that y value, okay? So let's think. If I want to isolate y, I need to get rid of the 2x. So this is just basic algebra. I'm going to subtract 2x from both sides. And so I end up with y equals 2 minus 2x. I can't combine those. They're not like terms. The issue, I like mx plus b in its normal order. So I'm going to go ahead and rearrange these, just flip them around and say, okay, well, let's put the -2x in the front. That would make that a +2 since it's positive. So I'm going to begin that graph at +2. If I go mx plus b, I'm going to begin at +2, and I'm going to move down 2 over 1. So down 2 over 1. It's close, but not a match. Down 2 over 1. Close, but not a match. Down 2 over 1. And this is where precision is important, because that looks like it might be a match, especially depending on how you drew your line. But you really want to hit one of these pink dots, one of these coordinates, okay? When I go down another one, down 2 and over 1, that's where I actually hit a dot that was already pre-existing, okay? So be very, very careful as you're graphing these that you actually hit a good intersection that you can rely on, not just, well, it kind of looks like they touch. That's why we do so many dots, okay? So that means that's my solution right there. And if I start counting, let's see, it's over 1, 2, 3, that would be over at 4, and it's down 1, 2, 3, 4, 5, down here at -6 because I went down. So my answer would be 4 for the x value, -6 for the y value. There's my x's, there's my y's, okay? So that's the answer to that one. Good luck.